Welcome back everyone, and today we're going to be turning uranium metal into X-rays. So the process we're going to be doing today is called uranotyping, and it's a very interesting process where you use light-sensitive uranium salts to make photographs, where more modern photographs use silver halides. So this was actually employed before silver halides came into use. Modernly it's digital, but old film used a lot of silver halides. But today we're not just going to be taking simple photographs with it, we're going to be taking X-rays with it because, well, that's way cooler. Interestingly enough, there's not much information on uranotyping. It's kind of bleak out there because it's a very old technique used in like the 1800s. So I actually came across this accidentally because on the Wikipedia page for uranyl nitrate, it has a section about its use in photography. And I was like, that is really cool. And then also, once I did further research, there's actually another YouTuber on YouTube that did uranotyping, which seems to be the only other person that has done it, and his channel name is Wheeler Scientific. Go check out his videos, they're really good. So yeah, let's go ahead and take some uranium X-rays. Yeah, ignore the glasses. I lost them in the ocean. Yeah, they got taken up by the waves, and yeah, now I'm stuck with these, which is some old lenses I glued onto some sunglasses frames. It works temporarily while my new glasses are coming in. Okay, and well, to first take our uranium photographs, we're going to need uranium. And that's what I have here. This was donated to me by Backyard Science 2000, so thank you them so much. Right now it's in some lead shielding, so it's not very radioactive, but we'll go ahead and open this up. And as you can hear and see, it lights it up fairly well. It is depleted, so it's not as radioactive as, normal undepleted uranium, but it is still fairly radioactive, around 28,000 counts per minute when it's right up against it. And this right here is about 1.2 grams of it. And now here's the moment of truth. I'm going to go ahead and very carefully open this. Okay, so now let's go ahead and actually open the vial. Uranium is toxic, so we have to be careful with this. It's not so much toxic because it's actually radioactive. It's more so toxic because the metal itself, acts as a heavy metal poison. So the radioactivity ain't gonna help anything too, especially if you ingest it due to the alpha particle emission. It's gonna be quite bad. But what I am going to do is transfer our depleted uranium into this graduated cylinder. I'm gonna be very careful to not get the dust anywhere. And there we go. There's only a little bit of specks left in the vial, and that's okay. But we got the majority of it down there in our graduated cylinder. Okay, now I'm going to go ahead and add roughly about a milliliter of 70% nitric acid into here to dissolve this into uranyl nitrate. So the nitric acid will serve as an oxidizer and form the nitrate salt. Go ahead and add that in. 1 milliliter, and as you can see, it's already starting to react, forming our uranyl nitrate. And now we'll go ahead and just let this dissolve. Okay, what I am going to do now is go ahead and move this to a hot plate. And I'm going to turn on gentle heating, just so, because later we're going to have to remove all the excess nitric acid. And I did add a bit more water in there to help dilute things out. But yeah, so we're going to have to kind of evaporate that, so I'm just going to go ahead and start giving it gentle heating now. Okay, it's boiling down a bit more now. We're pretty much at around the 4 or 5 milliliter mark, so I'm going to go ahead and turn off heating and let this slowly cool down. Most of our nitric acid should be out of there. There's only a little bit excess, so yeah, all we gotta do now is just wait for it to cool, and then we'll go ahead and dilute this and make our uranium X-ray. Okay, here's our uranyl nitrate solution now that it has cooled down. Well, it's still not fully cool because it hasn't solidified yet. But anyway, most of our nitric acid is out there. Pretty much all of it should be. Okay, so what I'm gonna go ahead and do now is add about 10 milliliters, well, up to the 10 milliliter mark of distilled water. So we're gonna go ahead and just dilute this. Okay, my tripod just gave out. Nice. Jesus, okay. And then over here, I have a diluted potassium dichromate solution, just a 1% solution. So I'm gonna go ahead and take this out and add about 8 drops of it in here. And there we go. So our sensitizing solution is done. And this is what we'll be using to make our x-rays. Okay, now I gotta go fix my tripod because it is struggling. Okay, what I am gonna do now is transfer our sensitizing solution. I'm just gonna transfer it like this into this bottle. Now we gotta keep this out of the light because this is sensitive to light, so it will start to degrade. Okay, so now our next step here is going to be to coat our papers and our sensitizer solution, aka our uranyl nitrate solution / potassium dichromate. Anyway, so right here we just have some small sheets of construction paper that I cut out, and these will be our individual pieces of x-ray paper. Okay, what I'm going to do now is take about a milliliter, actually even about half a milliliter of this solution will work, and we'll coat our paper in it. So I'll first start off with half a milliliter and see how that performs. Just like that, we got half a milliliter of solution. I'm just going to kind of plop it on the paper. And now I'm just going to go ahead and take this foam brush and spread it out along the paper. Okay, just like that, this is pretty much ready. All we gotta do now is put this in a dark place to dry. Okay, now it's time to make some solutions. Well, the first one's not gonna be a solution. This first bath is going to be just plain old distilled water. And now we gotta make our developer bath here on the left. Okay, so to our bath on the left, I'm just gonna take a couple spoonfuls of this potassium ferric cyanide. If you can see the name there, but yeah, potassium ferric cyanide, and this will be our developer agent. Okay, and just like the other one, I'm gonna go ahead and add a bunch of distilled water to dissolve up our ferric cyanide. And there we go, here's our potassium ferric cyanide solution. And this is pretty much all we're gonna need for our post-processing. Okay, here's our sheet of paper after drying. Let's go ahead and whack it with the Geiger counter and check if it is radioactive. And as you can hear by the clicks, it is definitely radioactive, but not by that much. It's actually pretty mild radioactivity. I'm getting around 800 counts per minute right now. Okay, so now we've got to protect this from light while we're doing our x-ray exposure. So I'm going to center that there in this piece of cardboard, and I'm going to sandwich another piece of cardboard right over it. Okay, here's what we got set up now. This is the x-ray power supply, the x-ray tube, and then we got our film in there sandwiched between these two pieces of cardboard. And yeah, hopefully this will expose the film. But now we just need something to x-ray. So we're gonna go ahead and just use this lighter. And I'll go ahead and tape that up there on the cardboard. Okay, just like that, it is all ready to go. Now I'll have to remotely turn this on and expose this. I really don't know how long this is gonna take. Probably quite a bit, because the uranotype is not very sensitive. So this is normally done under, okay, that fell. But anyway, this is normally done under UV light exposure, because the UV light will take that uranium 6+ state, which we have it in right now as the uranyl nitrate, and drop it down to the uranium 4+ state. So the UV light actually essentially reduces it down, and then our ferric cyanide will go ahead and complex with that, and then we can wash away the rest of the 6+ state, and bam, you have your photograph, right? Makes sense, if that does make sense. So yeah, but normally use UV light for this, but x-rays can do the same thing and also expose it. But yeah, I mean, I guess it depends on the intensity of the UV light versus the intensity of the x-rays. We'll just have to experiment and see how this goes. So yeah, we'll go ahead and I'll refix this and turn this bad boy on. I'll probably start with 5 minutes. So I got it running right now. We're hitting about 500 counts per minute back here. X-ray tubes face the other way. But yeah, I mean, really 500 counts per minute isn't really bad at all. Okay, so here's our first thing after exposure. Looks like it maybe has something there. I don't know. Let's go ahead and dip it in our ferric cyanide solution. This was about a 5-minute exposure. So yeah, we'll see. Interesting. Okay, well, I'm gonna go ahead now and give it the water washing, which is just back there. Well, what we're left with here now is pretty much abstract art at this point. It is radioactive. I'll get the Geiger counter out and measure here in a minute. But yeah, there's our first uranium attempt. I'm just gonna go ahead and buy some watercolor sheets because it's obvious that this just doesn't work. You can see where I originally dropped it on, how it just kind of soaks in and doesn't want to smear around on the surface. watercolor paper will, fix that. It's the next day here, and I just went ahead and bought some watercolor sheets. I should have just done this from the beginning. It's times when you try to go the lazy way and work with what you have. Yeah, anyway, so I went ahead and bought some watercolor sheets, which will make it a lot better. Because on the last one, you saw that those little dots kind of formed where it soaked into the paper. Well, watercolor paper more allows the liquid to bead on the surface, and then you can smooth it out over, so it's a lot better. So I went ahead here and cut out some sheets and stuff. So these will be our X-ray sheets right here. And then I went ahead and also cut out some test sheets. So I'm going to use these to test how long we should do our exposure for, so I know, how much to do for these, because I don't want to waste all the solution attempting on, these sheets. Instead I'll just do these really small ones. So yeah, let's go ahead and paint these up with our sensitizing solution, and yeah, we'll see what comes out. Okay, this time I'm also going to take more care to not have it exposed to really any light. So anyway, I'm taking it into the shed here, which is now cleaned out. A lot more spacious now, a lot more spacious. And I'm going to go ahead and resort all these on here. Anyway, and then we'll coat these with our uranyl nitrate sensitizing solution. Okay, now we just gotta go ahead and let these dry. But what I am gonna do is, I'm going to take one of these and put this outside and just see how it exposes. Outside we go, where the sun is nice and bright here in Florida. God, I hate the sun. So we'll go ahead and you can see it right there. I'm gonna leave it right there and let it expose. Okay, our thing has been exposed now for about 25 minutes in the sun. So let's go ahead and give this a test. So first the ferrocyanide solution. As you can see, it worked pretty well. I don't know what that precipitate is that's forming in there, but yeah, that looks nice. Okay, now we'll go ahead and move it over to our water bath. Okay, so here's our result, and that looks a lot better than the previous one. So much better. So I think this is going to work. So now we just got to test how long we should do our exposures on our X-ray tube for. I'm first going to start off with a minute, then I'll probably jump that up to 3 minutes and 5 minutes, then 7 minutes and so forth, and see which one gives the best results, so then we can go ahead and move on to that. So I will leave that there. I've created this thing to sandwich the film in between, so we don't get it exposed to normal light. And yeah, let's go ahead and set this bad boy up. Okay, here's our setup now. Got the X-ray tube here, and there's our piece right there. I don't know, what is this, about a foot? Somewhere around there. I don't know. Yeah, good enough. So yeah, we'll go ahead and expose it and see how this turns out. So first, a 1 minute exposure. And this right here is how I remotely turn it on and off the X-ray tube. I just flip the GFI breaker, and then yeah, that's how I control it. So very scientific. And then I see if it's running using my Geiger counter. Coast Guard plane. There it goes behind the trees. Okay, our 1 minute exposure is done. So let's go ahead and take this off. I don't really know if the 1 minute really would have done anything. The uranium salts are much less sensitive than, say, silver halides. So yeah, but we will see. So yeah, that didn't do too well there. Okay, well, we'll have to go ahead and give this another trial. Okay, so now I'm going to go ahead and run this for, I'm just going to bump it straight up to a 5 minute exposure, because I realistically don't think the 3 minute exposure is going to do anything. Okay, it's been 5 minutes of exposure. My tube is now leaking oil, because I think the pressure built up a little too much in there, because the tube does get pretty hot. So the oil expands and then builds up pressure, and looks like it is leaking oil. Okay, here it is after developing. Not much. I can't really see anything where it looks like a lighter was in there. If we're gonna need really good X-rays, we're gonna need a lot longer exposure times. On the other hand, what is going on here? There's ants like munching on the uranium nitrate paper. What? There's another one there. What the hell? I've never seen anything like this.
I mean, I haven't messed with uranium salts, so I guess I wouldn't have seen something like this. You know, I think I've seen this in a movie once with spiders. Man, there's more bugs on it. Man, why are they obsessed with this? What the hell? Let me give them a little pokesies and see what happens. Okay, this one seems effed up. Did he eat the uranium nitrate? This is strange. He must have munched on the uranium nitrate and got poisoned by it, because it's acting very weird.
So yeah, there's our attempted x-rays over there. And again, where the spot is, right, that's where more uranyl nitrate was. That's where I initially put the dot, and therefore to absorb more x-rays and actually expose better versus these areas where there's not much. It didn't expose very good. Because even though this x-ray tube is putting out more power than the UV rays that are hitting it, like in this one, you got to think that the UV rays are more absorbed, right? UV rays are not very penetrating, so they just absorb right on the surface, exposing the uranyl nitrate very well, and that's how you get that. But here, where the x-rays are mostly just passing through it, because it's just a thin piece of paper, it doesn't expose it very well, because most of the x-rays pass through without actually dumping most of their energy into the sensitizing solution on the paper. But in the middle there, where the sensitizing solution was more concentrated, more of the x-rays were absorbed there, and therefore it exposed it better right there. That's the best explanation I have for that. But yeah, we're still going to go ahead and do plan B, and it won't Piper Perry my x-ray tube, because I'm scared this thing's going to blow out. This thing was getting so hot it could barely touch. You got to think about it in there. The anode's metal, and then it has a glass envelope around it. Simple expansion and contraction in there could definitely cause that to break, which I do not want to happen. So I'm not going to push this thing any further than I need to. And we'll just go ahead and move on to plan B. Okay, so now we're going back to our normal mode of taking x-rays using the fluoroscopic screen in here. Yep, there it is back in there, and then using my phone to take pictures of it. So first we're going to be doing this light bulb, and we're doing this other stuff, and then we'll convert these x-rays into beautiful uranium x-rays. So yeah, just going to go ahead and x-ray all this stuff, and hopefully it comes out really good. Also, I've changed the settings in here. I changed the current in here because I realized that this was drawing about 5 milliamps. So we were definitely having a voltage sag in there because this thing was drawing way too much current. So I turned down the filament, which will have the voltage stay up higher. So we should get out better x-rays because they should be more penetrating and not as non-penetrating. Yeah, so just some things I've changed. Okay, so here's a quick montage of all the x-rays. And wow, they are amazing quality, so much better than my first x-ray video. It's funny, I have a spin-off video of my x-ray shenanigans, and it ends up being better x-rays than the actual x-ray video. It's really just about adjusting the current flow to the filament. Anyway, so some really nice x-rays, and tomorrow we'll turn these into our uranium x-rays. Okay, so here's our final product after printing onto a transparency sheet. You can see all of our x-rays there. Yeah, it's a laser printer, so the image quality is pretty crappy. It's not the best, but you can still make out the x-rays, which is good enough. And I don't really think the contrast is going to be too good because you can't really see the outsides of things. So what I'm going to do is, my idea behind this is that this is a transparency sheet, right? So these white areas is where light can come through, and that will expose those areas of the uranium sensitizer. And then when we develop it, right, the dark spots will be all these white spots here, and all the white spots will be the dark spots. So it'll invert it, but it should look like we have our x-rays on the photographic film. So
yeah, let's go ahead and try that. Well, first I'm gonna go ahead and cut these up into pieces. Okay, now it's time to sensitize our sheets. So we're gonna use our sensitizing solution of uranyl nitrate and potassium dichromate. Both nice carcinogenic chemicals. So yeah. Okay, now what we gotta do is take one of our transparency pieces, just like this, and mask it right over. We'll see how this does. Okay, I got it taped to the armrest. Oh my god, I think it's raining. You are kidding me. I don't know if you can see in there, but I've trapped a mosquito. Good riddance, motherfucker. Anyway, yeah, if it starts raining, I'll have to take this up, but for now, I will leave it like this. I'm gonna let it sit here for about 25 minutes. Okay, it's now been about 25 minutes. You can see that it has exposed on the edges, so I'm gonna go ahead and take this away and bring it back to the shop. Oh, that's really sticking to it. Yep, that's ruined. Nice. Nice, nice, nice. Awesome. Okay, it's time to switch up our strategy here because we can't just put it directly on there. That's not going to work, even though it is sticker paper. It sticks too well to it. Even though when I originally tested it, because I was like, hey, it's probably going to stick really well. When I went and originally tested it, it didn't stick like that. And now it does. Okay, I'm going to attempt to use this Pyrex dish. And then you can see it in there. Placing that over our uranium paper, just like so, and then exposing it that way. Okay, since the sun ain't really working with me too well out here right now, I'm gonna go ahead and just use a mercury arc tube. And this produces a lot of ultraviolet light. Pretty much just heats up mercury, vaporizes said mercury, and then that vaporized mercury emits a very specific spectrum in the ultraviolet range. So yeah, and these things are directly used a lot for sterilization, right? Because if you need a lot of UV to sterilize things, that's when you'd use it. Okay, I now have the mercury arc lamp running. I'm gonna want to stay back from it because it does produce quite a bit of UV. But yeah, we'll go ahead and let that run and expose our photo. That looks so eerie through the camera. Okay, so after exposing under our UV light here, you can see this is what we are left with. You can see a pretty good outline of where our X-ray is. So let's go ahead and develop this. Hey, honestly, that is not that bad. That is pretty good. Beautiful, just like that. Now what we gotta do is let it sit out and dry. Okay, so here's our first attempt after drying, and hey, it's not too bad. You can see it in there. And yeah, it looks like an X-ray because, well, it was taken from an X-ray. So let's go ahead and do our other ones over here. I'm gonna go with the multimeter. Also, if you want to look at the uranyl nitrate for lessing, look at that. That's awesome. Anyway, don't want to do that too long because then we'll expose our sensitizing solution. And it looks like my UV light has caught some moths and fried them, I guess. God, this whole thing has killed so many bugs. I kind of feel mean. But yeah, I guess they really liked the UV light. So let's go ahead and take this off. And I can see the outline of our thing there. Got quite a bit of moths. Get out of there. So let's go ahead and develop this. And that's what it looks like. That one actually looks pretty good. I'm pretty happy with how that came out. Okay, and like before, I think this one's gonna come out amazing. Look at that on there. I feel like it's gonna be amazing. This thing puts out a lot of UV light. I mean, I can literally smell the ozone. I've been running it for about 45 minutes to an hour. Even though this thing puts out a lot, I think that Pyrex dish blocks quite a bit of it. Okay, our second one's done now. So I'm gonna go ahead and grab it. You can faintly see it in there, and that's kind of what we're looking for. This might be underexposed, but we'll see. But there it is. That's pretty cool. Okay, now since the frame I'm going to put it in is going to look better with 4, I'm going to go ahead and make one more. So I'm going to go ahead and coat this with our sensitizing solution, and then we will make another X-ray. Okay, so here's our exposure. I'm going to go ahead and dip it into our developing bath like usual. Okay, that looks kind of effed up. You can see where it looks like it's double exposed. I don't know how that happened, but somehow I guess I mean, I did move it once, but I set it back exactly where it was because I had it marked. And I don't know. Yeah, that's pretty effed up if you ask me. But you know, good enough. It still looks kind of cool, so it's gonna go on the poster board. So here's our final product: our picture frame full of our uranotypes, our X-ray uranotype. So we have our X-ray fluorescence screen here, our X-ray battery charger, X-ray. This was a RF meter or something along those lines, and then we have this multimeter here. So all pretty cool, really awesome stuff, and yeah.
Okay, well that wraps it up for today's video. I know I'm on an X-ray binge again. I just brought the X-ray machine and I was like, yeah, screw the other video ideas I have. This is what I'm doing because it's just so fun playing with the X-ray machine. Anyway, so yeah, we got one more video after this doing X-ray stuff. It's gonna be a really cool video. But yeah, that's about it. Hope you guys enjoyed, and I'll see you guys next time.